State Classroom. I'm your tutor, Shaquille Lewis. I'm a graduate student here, and today we're going to go over integration by parts. So integration by parts is a useful method when you have complicated integrals that are really hard to integrate. So it gives us an easier way to solve these integrals. So I'm going to do an example problem to show you how to utilize this method. So for my example problem, I will solve this integral. Let's see here. All right. So you have this expression. It's very hard to find an integral that will work for this. So we're going to utilize integration by parts to make our lives easier when we solve this expression. So the first thing you want to do with integration by parts is to decide which of these you're going to call u and which of these you're going to call dv from this expression. Now, if you notice, when you're changing from one integral to another, this u gets differentiated, you end up with a du. So if I were to take x squared and set that equal to u, then that means du would equal 2x. So I just reduced x squared down to 2x, and you'll see why that's important in a few moments. Now, I'm going to take my dv and say dv is going to equal to my remaining term, which is my sine of x. And now, in this expression, I have a v, so that means I have to integrate in order to get my v on this side. So v is equal to the integral of sine of x. So you have derivative of sine is cosine. After cosine is negative sine. And after negative sine is negative cosine. So if I have sine of x, then that means that negative cosine is what the integral of sine of x will be. So you have negative cosine of x, because the derivative of negative cosine of x is sine of x. Okay. So now you have your u, you have your du, you have your v, and you have your dv. And at this point in your expression, it's basically plug and chug. So now we're going to use this information here to rewrite this statement. So now, integral of x squared sine of x dx will now equal u x squared times v, negative cosine of x, minus the integral of v, negative cosine of x, and du, which would be x squared du. And now you have this expression. I'm going to rewrite a few things to make it look a bit neater. Let's say this is equal to negative x squared cosine of x plus the integral of cosine of x. Actually, one moment. This is a mistake. This should be a 2x plus 2x du. Okay. That is correct. Now we have this expression right here. We've changed it from this into this form. So I can bring this down and say integral x squared sine of x dx is equal to this expression now that was formed by using integration by parts. So we have one component of our expression that doesn't require integration, but we still have this component right here that requires integration, and we're met with the same problem. We have these two variables that are multiplying each other, which makes it difficult for us to integrate directly. So now we're going to use integration by parts again on this section. So I'm going to erase what we had before. And now I'm going to do integration by parts on this section right here. So I'll erase the section we worked on previously. Okay, so now we have the integral of, I'll rewrite it as x cosine x dx. Now, same principle applies. We want to keep reducing down the term so we're left with one term to deal with in the integration. So I can say my u is going to equal x. That means that if I were to take the derivative of this, this would be du equals 1 dx, because the derivative of x is going to be 1 dx. All right? And now my dv is going to be cosine of x. And this just came from over here because, just to reiterate, I'm using integration by parts on this section. So we use the same thing. Derivative of sine is cosine. Negative cosine is negative sine. Sine negative cosine sine. So if I were to integrate cosine, then I would get sine. So now that's going to tell me that v is going to equal sine. Okay. Sine of x. So now I'm going to use the same formula for integration by parts to evaluate this section and put it into a new form. So now this, using just plugging and chugging what I just solved out. So I have u x times v sine of x minus the integral of v sine of x times du, which would just be 1 dx. And now you have this expression. Now, I want you to notice in this integration is just the integral of sine of x. And that is something that's very easy for us to integrate. We can know that off the top of our heads or looking in an integration table. And the reason that it's so much easier now is because we chose a u that would reduce its exponent each time we used integration by parts. So we end up with an expression with only one term in the integration that we can solve out. So that's one component. Now you have to remember this section came from over here. So now we have to plug this back in place of this. So now I'll erase my work. Okay. And I'm going to plug in. I'm going to rewrite this and then plug it back into my expression. So integral x cosine x dx equals x sine x minus integral sine x dx. Okay. And so now I'm going to plug it back in. So the integral of x squared sine x dx, which was our original problem, is now going to equal negative x squared cosine x plus 2. And now we're going to substitute this section that we just solved out for, because it's the same thing as what's over there. 2 times x sine x minus integral of sine x dx. And so now we're left with this expression. And now it's easy for us to evaluate the integral of sine of x. So same thing. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Derivative of negative cosine is sine. So that means the integral of sine is going to be negative cosine. So we can now just know it from our rules that we learned in class, or from looking at integration table, that this is going to equal negative cosine of x. So now we can say the integral of x squared sine x dx is equal to negative x squared cosine x plus 2 times x sine of x, and we said it was negative cosine, so that'll be plus cosine of x. Alright, so we did all our work already, and so this is our end product. The integral of x squared sine of x dx is equal to negative x squared cosine x plus 2 times x sine of x plus cosine x. And don't forget, this is an indefinite integral, means we didn't label what our bounds are, so we have to put the plus c, which is our constant of integration. If you do various other problems, you might have to solve for that constant of integration. So just to break it back down, you see that we started out with a problem asking you to solve for this integral of x squared sine of x dx. And by choosing what we said was u and what was dv, we're able to apply integration by parts twice to break down this complicated integral into this integral right here, which is the sine of x dx. So we end up with an expression of minus x squared cosine x, which comes from the u times the v. We ended up with the x sine of x right here, which is also u times v. And then we ended up with an integral left behind, which is just integral of sine of x dx, something that's very easy to solve. And once we apply the integration by parts twice, and we chose our u and our dv correctly, so it would reduce the problem to something simple, we end up with this end expression. And that's it.